Hello, Matrix, and welcome again. Today we are carrying on with financial maths, and I want to look at paying off a loan and how many payments you need to make in order to pay off a loan if you're going to put, say, 5,000 each month into the loan. So this is tricky because when we calculate n, we see that n is in the exponents. It's an exponent, and so we have to use logs. So I've done one of those videos before, but I'm going to do another one. So in the last video, I said I would be showing you how to make the final, to calculate the final payment of a loan. But I like to use these past paper examples because these questions are never in isolation. So 7.2.3 of this question is how to calculate the final payment of a loan, because the balance outstanding formula that we used in our last video didn't necessarily work. So if we get to that, if there's enough space, we'll do 7.2.3. But first, I just want to go through this question, and then perhaps in the next video, we'll finally get to figuring out that last payment. So I've got this past paper question which says, Genevieve took a loan out from the bank of 82,000 Rand, and she makes her first payment on the 1st of February 2019. So she makes her payment a year after she actually took the loan. And she says she's going to make payments of 3,200 a month, and the bank charges 15% per annum compounded monthly. So the first question says, what is the value that Genevieve will owe the bank on the 1st of January 2019. So of course she doesn't start paying the loan until February. So we're going to get that 2018 is going to start earning interest. Well, not earning interest, but the bank will start charging interest because that's what they do, right? So we're going to find the future value of a loan. Okay, and so it's not a payments formula, it's just a simple future value formula. So we're going to use the one in orange because this is the value of the loan at present, which will be 82,000. So 7.2.1 is going to be then 82,000. And then how many months from February to January? Well, it's going to be 11, right? So the whole of February, March, April, May, June, July, August, September, October, November, December. And then, of course, the 1st of January, so it doesn't count because that's the 1st of January. So it's 11 months. So 1 plus 15% over 12 to the power of 11 is going to give you, put it into the calculator there. I've already done that first one. Nine four 0 679. Okay, so that's the first one, 94006 Rand and 79 cents. Okay, now 7.2 says how many installments. So this is paying off a loan. So we think paying off a loan, the green, okay, P, paying off a loan and its installments. And so the loan she takes out is on the 1st of January. So it makes sense that she'd start paying on the 1st of February, right? Because you don't start paying the loan straight away, because then you might as well just take the loan out as one payment less than what it was for. So basically let's put this simply. And I've said this before, if you take a loan out from your friend for 10,000 Rand, and he says, well, you need to start paying straight away. So he gives you the money and then you give him back 1,000 Rand on the same day, you pay it off. Well, that makes no sense, right? You might as well just take a loan out for 9,000 Rand. So you're always paying a month after you take the loan. So the formula takes into account that you're paying 1 month after. So if the loans, if you've calculated the value of the loan on the 1st of January, you start paying on the 1st of February, you use the formula as usual. So we can put in this 94006 Rand and 79 cents equals, and then the payments are 3,200. And then it's square bracket 1 plus the interest of 15% over 12. You can put that as 0.15 as well if you are so inclined. To the minus n is what we don't know. So let's put that in red. Over 15% over 12. Okay, so what we want to do is let's get these square brackets by itself for now. So let's pretend you don't have a fancy calculator that just solves it. We're going to have to figure it out using our knowledge of maths. So to get the yellow by itself, we would simply just divide what's in front of the yellow by this. So we could just divide this by 3,200 over 15% over 12. So let's do that. So let's take that 94078. Okay. Now, if you've got the memo, we're not rounding, so we might get slightly different answers because we're just going to use the 940 that we've got there. And so we've got divided by the 3,200 over the 15%. 15% over 12. And we get 0,3672. Okay, so that is now equal to the square yellow bracket. So we can say that 0.3672 ... equals the square bracket 1 plus, and now we can drop the square bracket. We can just say 1 plus 1 plus 15% over 12 to the minus n. And now we can just take the 1 across. So we're just going to say minus 1. And we get negative 0.6327 ... equals this P is always a minus. Just need to check that. So when you must always get a minus and a minus because you can't find the log of a minus. Well, you can't have log minus as your the number. So then we get 0. This now is negative 1 plus 15% over 12 to the power of minus n. And so the negatives go away. So let's just take those negatives away because you can divide by. And so now we can use logs. So because logs is the way we get our exponent. So negative n equals, and we're going to say log base number. So it's log. The base is the thing at the base of the exponent, which is 1 plus 15% over 12 to the power, and then it's the number 0.6327 ... Okay, so now let's actually just write a few numbers there. 632786. 632786. Okay, now we can put that in our calculator. Clear this, and we're going to say log this button here, and it's going to be 1 plus, and then it's the brackets, 15% over 12, and then this value here is 0.63278. Now what was that? It was a 5 or 6. Okay, let's just make it a 9. 63279, and we get 36 payments, so we get 37 payments. Because it's negative n equals negative, so therefore n equals 36.83767. So n is equal to 37 payments. Because we always round up, because there's going to be that final payment. Now, I'm not going to have time to do the balance outstanding formula, but there is, so I said that you couldn't use this green one. You actually can. There's a little trick here. Is you can say, you know, the value of the payments is 3,200. And what you can do is this fraction here, the 8377 is what you're concerned with. And that you can put in the fraction part. And so it would be 15% over 12. And you say it to the power of negative, and you just put this fraction bit, the 83767. Okay. Over 15% over 12, and you can put that in and we can get the value of that final payment. But of course, that needs to have also, that is not the value of the final payment. That's actually the balance outstanding before the final payment, which you then have to give 1 month's interest to. So let's see what that is. We put that in our calculator and we say equals. Now that is going to be the value before we add interest. Well, we've got to add interest for 1 month. So we quickly just add interest onto there. So equals. Okay, so let's just get that value down. 2650.116 is the value, but then we need to multiply that by 1 plus the interest, which is the 15% over 12, but it's only for 1 month. And so we're just going to do that. We're going to times that by 1 plus 15%. You can put 0.15, as I've said a number of times. I just like to put the percentage in because it avoids any careless mistakes with decimals. And so we get 268325. Okay, so that would be the answer to 7.2.3, but I want to just do another method in the next video where we'll be looking at the final payment using this balance outstanding method here, which I've got at the top. So please subscribe, like, all that good stuff, and I will see you soon. So you